This lesson is about solving formulas. What is a formula? Well, this is a general rule describing relationship between various quantities, usually variables. So it's basically a recipe how to calculate a certain quantity knowing the values of the variables. Let's look at various strategies that we can use to help ourselves solving formulas. The first suggestion that I will have for you is highlight the variable that you are solving for. So for example, if you would like to solve the formula 2L plus 2W equals P for L, it would be good to highlight the L. This helps us to focus our eyes and our minds on this particular variable. Pretend that everything else works like a number. So even though you see some letters here, pretend those are just regular numbers. That will make it easier to solve the formula. So in this case, to solve for L means that we wish that in the end we'll have L by itself on the left-hand side and some expression that involve other quantities on the right-hand side. Okay, how can we get closer to L? Since L is strongly connected with the 2 by this multiplication, then let's leave the 2L till the very end and get rid of the 2W to the other side. So what we need to do is undo this addition, meaning we need to use subtraction. Okay, so formally we're going to subtract from both sides of this equation 2W, and then we'll end up with 2L, and this plus 2W will travel to the other side with opposite sign because we're subtracting 2W. So it will equal to P, the same as it was, and 2W becomes negative 2W. Okay, we are very close to L. Now the only thing that we want to get rid of is this coefficient 2. So since there was a multiplication between L and 2, now we're going to divide by 2. And our formula is already solved. L equals P minus 2W, everything over 2. Notice that this expression could be also written in different form. For example, we could say L equals, and then we could separate this fraction into two fractions, P over 2 minus 2W over 2. However, the 2W over 2 can be reduced, so overall this formula could be given as P over 2 minus W. So either like this or like that. Both answers are correct. The next suggestion would be to make sure that the variable that we are after is always in the numerator, not denominator. So if we want to solve this formula r equals d over t for t, we wish to have the t in the numerator. How to do it? Well, again, by using inverse operation. Since we divided by t, let's multiply the whole equation by t. That will cancel this denominator t, and the t will actually travel to the other side as a numerator. We still had the r, and this equals to d. So now it's just one more step. We want to get rid of the r. Formally we divide by r. So we end up with t by itself, because r will be cancelled, equals to d over r. And our formula is solved for t. I would have one more remark here. These two operations we can actually do at the same time. Just remember that if we deal only with multiplication or division, we can always switch the letter to different level by moving it to the opposite side of the equation. So the t will go up and the r will go down. They really swap their places. I call it teeter-totter. That's really easy to remember. Whatever is in the bottom goes to the top, whatever is in the top goes to the bottom. So we don't really have to perform these two steps. We could switch those letters at once and give the final solution in just one step. The t will go to the top, the d stays where it was, and the r goes to the bottom. Teeter-totter. The next strategy that we can use is to reverse operations, undo the operations. For example, if we want to undo the addition, we use subtraction. To undo the multiplication, we use division. And to get rid of power, we use a root with the same index. So let's look at this example. Here we have a formula for area of a trapezoid, where A and B are the two bases of a trapezoid and h is the height. So let's say we could have base B here, h over there, and base A here. So to get the area of this shape, what we do, we take average base, because this one is too long, this one is too short, but if we take average, it will be exactly right, times height. So similar idea as in a rectangle, base times height. However, the base is actually average base, a plus b over 2. Okay, so we know what this formula stands for, but let's say we would like to solve for a. That means we would like to get rid of all other numbers or letters that are around the a. So we do that starting from the farthest operation that needs to be applied. In this case, the farthest operation is division by 2. When we track the operations that a is subjected to, the first thing that we'll do to a is addition, we're adding b, then multiplication, while multiplying by h, and finally division, we're dividing by 2. So to reverse this process, we're supposed to undo the division, which means we multiply by 2. We could record this somewhere on the side, multiply by 2, but at the same time, we're going to undo the multiplication by h, so let's divide by h. You see, similarly as on the previous slide, we're using the teeter-totter situation. The top number goes to the bottom number goes to the top. Okay, let's perform this multiplication. So if we multiply the left-hand side by 2 over h, this h and this 2 will be cancelled. We end up with just a plus b. We don't need to write this bracket anymore because we already cleared the h and 2. And on the other side we have a, that is our numerator, and this a will have to be multiplied by 2 and divided by h. So exactly teeter-totter, h goes down, 2 goes up. Okay, so we're very close to a. Now the next step would be to get rid of this addition of b. So to undo the addition, we are formally subtracting b from both sides. Therefore, we obtain a equals 2 capital A over h, and then subtract the b. The final answer can be given this way, or we could rearrange this by placing everything under common denominator h. So the first numerator stays the same, 2a, but the second part, in order to gain the denominator h, we formally multiply the top and the bottom by h, which results in this expression, 2 capital A minus bh over h. Okay, now let's clean up this part. Therefore, the final answer could be given in this form or in that form. And another strategy that we can keep in mind is to make sure that the variable is positioned in one place. For example, this equation has the variable that we're solving for, which is r, in 2 spots, in 2 places. We would like to have it in one spot in order to leave it alone. So the idea is to take this common factor and factor it out. What's in a bracket is pi plus 3, which is equal to capital P. Okay, since we want to leave r by itself, we need to get rid of this multiplication by the bracket. So formally we are dividing by the whole bracket, pi plus 3. The pi plus 3 will travel to the denominator to the other side. Okay, we end up with r equals capital P over pi plus 3. And the question is done. Let's see this application problem. A sheet of standard size copy paper has the width W 8.5 inches and the length 11 inches. A ream of this paper has 500 sheets and a volume 187 inches cube. If x represents the thickness of one sheet, write a formula for the volume V of the ream in terms of the width W, length L, and thickness x. Okay, we need to figure out the volume of the box of this rectangular prism of paper. So what's the volume of a box? Well, it is the product of all three dimensions, the width, the length, and the height. So width W, length L, and the height. Okay, but we don't have the height. This is the height from here to there. How can we express height in terms of the thickness of one sheet of paper? Okay, imagine we have 500 sheets stuck on one place. So if I zoom this corner, how does it look like? One sheet, second one, third one, and so on and so on. It's 500 like that. So this is 500 sheets. Each sheet has a thickness of x. So we stack this thickness of x 500 times. That means the h is actually the same as 500x. Okay, so we can write our formula without h but with x as, let's start with numerical value first, 500 WLX. So volume is 500 WLX. Now solve this formula for x. Since we want to solve for x, let's mark the x in different color, for example blue. And now we want to leave the x on one side and bring everything else to the other side. But this everything else is connected by multiplication. So we can really think about teeter-totter. The top factors goes to the other side as a denominator. Okay, therefore x would be equal to, stay with v, and put the 500 WL in the bottom. Obviously the x could be written from the right hand side or we could write it from the left hand side. So maybe let's do it. It may look like this. And we're going to erase that part because that's the form that we are more accustomed to. And the last point, what we need to do is evaluate this formula to find the thickness of one such sheet of paper. Okay, so now we want to evaluate this formula. That just means we need to plug in the given values for V, W, and L. So, what is it? V is 187, 500 as it was, times W, which is 8.5, and times L, which is 11. The rest is a calculator job. Please calculate this on your own. You're supposed to end up with 0.004. And let's double check the units if they agree. In the numerator we have volume, which is inches cube. In the denominator we have width in inches and length in inches. So the 2 inches are cancelling 2 of the inches from the top and we end up with just inches. So yes, the denominations agree and our final answer is in inches. So we have 0.004 inches. I'm a metric person. Can we actually change this into millimeters? We know that 1 inch is 2.54 centimeters. Well, that will be 25.4 millimeters because there's 10 millimeters in 1 centimeter. So how can we convert this 0.004 inches into millimeters? Well, we need to multiply by 25.4. Okay, let's try it. 0.004 times 25.4. That will be approximately 0.1 millimeter. It's a little bit more than that, but tiny bit. So 1/10 of a millimeter. That makes sense for a thickness of paper. Notice that this question leads us towards the final answer by asking to write the formula, by asking to solve for the desired variable, and finally evaluate the formula. But imagine that we may not have those steps written. We may have just the original problem and we need to solve for x by ourselves. I'm sure you will agree with me that having a formula for x helps us greatly to calculate the x, but not only for this question. Imagine that we may have some other type of paper, other package. As long as we have the volume and the width and length, we could use this formula for many other instances. So knowing how to work with formulas would help us greatly in solving various problems.